Is it a function? All right. So, gonna play a game. You gotta have game plan, right? Love this game. So our game plan: solve for y. So if I have x squared plus y equals 4, to figure out if this is a function, what would I do? So I'm so sorry, I still can't hear you. I don't need a 0 per se, I need to get y by itself. All right. That's so embarrassing when you can't hear what people are telling you. Now that it's solved for y, I need to look at it. What I need to think to myself is if I were to pick an input, if I were to pick an x, how many different y's could I calculate from that one x? So let's say you picked an x. When you square that x, how many different numbers would you get? 1. And if you took 4 and subtracted that number, how many different numbers would you get? 1. I mean, if we all picked like 5 for x, 5 squared is 25. It's not like it's 25 or something else, right? And then 4 minus 25 is negative 21. There's only one way to do that. So, since every input has exactly one output, what does that mean about this? It's a function. Ding, ding, ding. Isn't this a great game? I love this game. All right, what about this one? It's similar. So how can we do this one? All right, so I can subtract x squared again. So y squared equals 4 minus x squared. Take the square root. So y equals, what would I get here? No. Because of the minus, you can't just take the square root of the individual pieces. You have to have the square root like this. There we go. As you took a square root to solve it, so if you take an even root in the solution of a problem, you have to throw a plus or minus on there. So what does that mean about this one? It has what? More than one what? Sort of. If you choose an input, it would have more than one output. So let's say that you picked 1 and I picked 1. 1 squared is 1, 4 minus 1 is 3, and the square root of 3 is the square root of 3. But you could pick positive square root of 3, and I could pick negative square root of 3, and we would have the same input but 2 different outputs. In terms of function land, that's bad. So that would mean that this is not a function. Those are the only two examples I had for is it a function. It's kind of sad. Sorry to say that our game is over. I'm sure everybody had fun. All right. Let's talk about function notation. During is it a function, we decided that this right here was a function, right? So we can give it a name, like f of x. X is the input, and f of x itself, just like it was y, is the output. Now, let's say I have a different function. We'll still call this f, though, because we're creative like that. X squared plus 3x plus 5. Now, let's say I want to calculate f of 2. How would I go about that? Yeah, plug in 2 for x. Because whatever goes in here is what your input to the function is. So this would literally be 2 squared plus 3 times 2 plus 5. That comes out to be what, 15? 15. So the input was 2, the output's 15. What about something like this? Yeah, so wherever there's an x in this original, I plug x plus 3 in its place. Remember, if I believe I mentioned this last semester, there's nothing mystical about this x. Here it's like a blank. So wherever there's an x, whatever's in here, you plug in its place. So this would look like x plus 3 squared plus 3 times x plus 3 plus 5. Now all we have to do is figure out what that is. What's x plus 3 quantity squared? Don't know, figure it out. Mm-hmm. Then we would distribute this 3. And then you just combine your like terms. So this would be what? X squared plus 9x plus 23. How would this one work? Right. You just have to watch your parentheses here. Because I have to square the whole thing there. Then this would be plus 3 times negative x plus 5. What happens when I square negative x? Right, it becomes positive. So this would be positive x squared, but this will become minus 3x, and plus 5 will be the same. Now the next statement I'm going to make is one of the most obvious statements I've ever made. The graph of a function is the graph of its ordered pairs. Well, duh. So let's briefly talk about graphing. And pretend, if you will, that you don't necessarily know what the graph of this looks like. You give grid. Don't you wish you could do that on regular paper? Me too. I have to draw all these by hand in my notebook, so. Or I did. Whenever I made this notebook, which would have been, let's see, the first time I taught college algebra would have been the fall of 2012, I think. Yeah. All right. Say what? Oh. All right. Now, if you didn't know how to graph this, which you should know how to graph that, but if you didn't, you could always make a chart, right? So here's x, and here's f of x. So if I pick some values for x, if x is -2, what's f of x? This shouldn't be hard. If I plug in -4, there we go. What about the next one? -2. Good job. 2, and then 4, right? So then I can plot all this stuff on here. So -2, -4, -1, -2, 0, 0, 1, 2, and 2, 4. And then I can connect them like so. And yay, you get a line. What if I had g of x, which would be 2x plus 4? Well, I can piggyback off of this chart. So here's g. What's g of -2? Plug in -2, what do you get? To g? Seriously? What's 2 times? Yes! And the next one?